The second half of 4.3, so 4.3b, is when we actually multiply two matrices together. Okay, so Friday we worked on just multiplying a matrix by a scalar. That was one number, so we multiplied each element by that number. But now it's a little different, and actually it's very different. We're going to multiply matrices. So our first blank here is matrix multiplication. In matrix multiplication, we multiply the elements of each row for the first matrix, okay, so row of the first, by each column of the second. Since we have to be particular about what we take from the first and what we take from the second, it is extremely important to know that order matters. The order that the matrices are written definitely matters. Okay, it is important. If you change the order from the problem that they give you and you flip-flop it, you're going to get completely different answers. Okay, so don't do that. Once we multiply the elements of the row of the first times the elements of the column of the second, we'll add the products. All right, now for this first example, like always, I'm going to write it out and really break it down. Now I recommend you also write it out the way I do for this example so that if you get lost later you can come back to it and it won't be so jumbled, so you can see exactly what happened. So of course I recommend to write down what I write down. So it says find the product of first matrix and the second matrix. Now, just to kind of have reference here, I'm going to call the first one A and the second one B. So write those two together. Don't write them too big because we need some space. So -1, 0, 3, -4. And then we're multiplying, so we write them right next to each other. -3, 3, 5, and 0. So we need to multiply the elements of the rows from the first. So we are going to take the first row in the first matrix, multiply it by the first column in the second matrix. All right, so let me show you what this looks like. This will give us our, well, we probably need more space than that, so I'm not going to put that bracket there yet. This will give us our row 1, column 1 element. So we will take -1, the first element, and multiply it by the first element over here. So we'll take -1 times -3, and then we'll add it to the next one, which is 0 times 5. That gives us just one element. Everything else we haven't done yet, so I'm going to leave that as question marks. Okay, now just simplify. So I've got -1 times -3 is 3, plus 0 times 5 is 0. Still don't know my other 3 elements. We'll do those in a second. Not a second, but a minute, more like, or more. So we simplify, and we get 3 as that very first element, row 1, column 1. Now let me go back and kind of retrace our steps. So we took the first row and the first column, and together it gave us row 1, column 1 element. Now, in that, we took first element times first element, and then added second element times second element. So that's where we got -1 and -3 here, and 0 and 5 here. We simplified and added them together. So there's a fourth of our problem. We still have the other 3 here. So I got to keep going. I've got I'm going to rewrite it out here so we can see it and not get confused. Write down the original problem. Okay. Now, so far I know this 3. Now, I'm going to take, still keep the first row, and then take the second column. So this is row 1, column 2. So in our answer matrix, we'll get row 1, column 2. So it'll go right here. And we'll get the first element times first element. So that's -1 times +3 plus second element times second element. We don't know the bottom 2 elements yet. Simplify. Let's see if I have any room over here. So we'll get 3, don't know the bottom ones. And then what's -1 times 3? Well, that gives us -3 plus 0. So that gives us just -3. So now we have half of our problem done. Let's keep going. Again, for sake of not being able to look back at this and not be confused, I'm going to write it out again. Okay, so far we've got a 3. Oops. I want to keep my color straight. 3 and a -3. Leave a question mark there, and I want another color. I'll go with lime green. Now, we are looking for second row, first column. So I'm going to take the second row from the first matrix and the first column from the second matrix, from matrix B. So we have second row from matrix A, first column from matrix B. And when we multiply the elements together, we get 3 times -3 plus, it's going to be close under, -4 times 5. Now, when we simplify that, let's see, we get -9 minus 20. So I've got 3, -3. Now I have -9 minus 20 is -29. And then we've still got one more. So for that one, we were looking for the element that was going to go in row 1, column 2. So we will take, from matrix A, we will take row 2. From matrix B, we took column 1, and we put them together. Multiply the first elements together and the second elements together. We got -29. One last one. I'm going to write it out again so we can see it and not get confused, hopefully. Need another color. It's a pretty color. So for this one, let's fill in what we have. Oh man, we've got having color problems. Okay, we've got 3 there. We've got -3 there in row 1, column 2. We've got -29, and then we are looking for row 2, column 2. So that's what I'm going to circle. Row 2, column 2. What will be my first 2 elements multiplied together? 3 times 3 plus -4 times 0. Close on room again. Fill in what I already know. and then simplify the last element. So that's 9 plus 0, so it's just 9. So my answer is the matrix 3, -3, -29, 9. Now that may seem like quite a bit of work for one problem, but if you consolidate it on your paper and don't take a line for every step, then it won't be so much. So just go, but the deal is you got to keep it straight. So go through and do row 1, column 1, fill in that blank, and then row 1, column 2, fill in that spot. Row 2, column 1, fill in there. Row 2, column 2, fill in there. And it won't take up so much space. Gives time for people that haven't written down to catch up. I'll let you have a little time right quick here. All right, if you still haven't copied it down, go ahead and ask Miss Landis to pause it. But if not, let's keep going to the back. So sometimes matrix multiplication cannot be done. Okay, so there is a solution to matrix multiplication, let's call it A times B, only if, this is very specific, the number of columns in A, being our first matrix, equals number, I totally ran out of room, of rows in B. So this is the only time really that instead of RC, like RC Cola, we've kind of switched it around. We need the columns in A to equal the rows in B. So let's just look at this without numbers. We're going to look at it first as letters. It says if matrix A is a M by N matrix and matrix B is an M by N by P, then the product matrix AB is an M by P matrix. Okay, blah, blah, blah. Sounds like a bunch of gibberish. So let's look at it. We're going to take A and multiply it by B. So the dimensions of matrix A are M times N. And we're multiplying it by matrix B, which is N by P. So up here we said the number of columns in A, which is right here, has to equal the number of rows in B, which is right here. So these middle two numbers have to equal each other. If those do not match, the problem will not work. Can't do it. All right? So, and what happens is when they match, kind of they disappear, and all you have left is your M and your P. So the dimensions of your resulting matrix will be M by P. Okay, so just cross out those like they're not there. And then you have your, what's left is M by P. Let's do an example with numbers. Say we have a 3 by 2 matrix and we're going to multiply it by a 2 by 6 matrix. Do the middle numbers match? Yes, so that's good. We can do this problem. And what will be the resulting matrix? What size will it be? 3 by 6. Just mark those out like you can't see them, and all you have left is 3 by 6. Sorry, I meant mark them out like that. Okay. Now, like I said at the very beginning of this lesson, order matters. So if we switch the order of that one, if we had 2 by 6 multiplied by 3 by 2, Can we do that problem? Is there a solution to that? No, because 6 and 3 do not match. So that one would be undefined. All right. Now I kind of jumped ahead because that's what the next example is about, but we just did a little practice. So it says use matrices G and H and determine whether the products GH and HG are defined. So can we do it? Does it exist? Or undefined? We can't do it. It doesn't exist. Find the dimensions of each product matrix. So first of all, for G, what are the dimensions? Remember, dimensions go rows and columns. So it's got 1, 2, 3 rows by 1, 2 columns. Now what about H? H has 2 rows and 2 columns, so it's 2 by 2. All right, we need GH. So for GH, it'll look like 3 by 2 multiplied by 2 by 2. How do we decide if this exists or not? Do the middle two numbers match? Yes. Okay, so it is going to be defined. And what will the resulting matrix, what size will it be? When we multiply those together, we would get a 3 by 2 matrix because we'd cancel out those. Oops, wasn't using my arrow. We'll cancel out those, and all we'll have left is a 3 and a 2. All right, let's do H times G. See if it'll be the same. So for H, 2 by 2 multiplied by 3 by 2. Can we do this one? No, why not? Because those two numbers do not match. So this one is undefined. And since we can't do it, there is no answer matrix, so we have no dimensions. Okay, so these would be our answers. Now, we didn't actually do an example where we multiplied two matrices together that were different sizes, so I want to go ahead and do that. Now, I'll do a problem off the homework, so if you would like, have Miss Landis pause the video while you get your homework papers ready, and then start it up when everybody's ready to go. Oh, except regular and pre-AP, y'all have different problems, so I'm going to do a problem off the regular homework. So pre-AP, y'all might want to write it down, but it's not actually off your homework. Sorry. So I will do problem 18 here. Okay, what are the dimensions of the first matrix? Well, it's 3 rows by 2 columns, and the second one is a 2 by 2. So can we do this? Yes, and our answer should be what size? 3 by 2. So that kind of gives you a hint of what you're looking for your answer, so if you get something else, you probably messed up. All right. So we are going to take, for filling this thing in, we are going to take, for our first element here, we need row 1, column 1. So we will take row 1, column 1, and that'll be 1 times negative 1 plus, what's 0 times 0? It's just 0. Okay, if you want to go ahead and simplify it, we can. I'll just make a new matrix down below. So what's 1 times negative 1 is negative 1 plus 0 is just negative 1. Okay, now let's do this one. So that's row 1, column 2. So I take my same row and then I multiply it by the second column. All right, so that'll be 1 times 0 plus 0 times negative 1. Okay, both those have a 0 and they're being multiplied. So what happened? Each thing is 0. 0 plus 0 is 0. All right, next one. Using all my colors, we're looking for row 1 or row 2, column 1. So I take row 2 in column 1. Negative 1 times negative 1 plus negative 5 times 0. Well, those are 0, and negative 1 times negative 1 is 1. Okay, next one, I'm going to look for here. So that's row 2, column 2. So I take row 2, column 2, negative 1 times 0 plus negative 5 times negative 1. Those together, let's see, that one goes away, it's 0. Negative 5 times negative 1 is just 5. We're doing good. I need more colors though. This orange color. For this spot, it's row 3, column 1. So I take my third row and my first column. 0 times negative 1 plus 3 times 0. Well, what happens? They both have zeros, so that one is just 0. For the last one, we're looking for row 3, column 2. So I take row 3, column 2. So that's 0 times 0 plus 3 times negative 1. Zeros cancel each other out. 3 times negative 1 is negative 3. So there is our answer. Did we get our 3 by 2 matrix like we were supposed to? Yes, we did. All right, that's all I have for you. So go ahead, do your homework. The first, well, I would say 8 problems, but we just did one of them. So this is for regular classes. Your first 7 problems are multiplying, and then the last 10, you just have to say whether the product would be defined or undefined. You don't actually have to multiply them. All right, get to work and make good choices.